In this video, we will practice estimating the value of a function at a point using Euler's method. This is a BC only topic. This is the practice video, so I'm just going to be running through a few examples with the assumption that you already have a basic understanding of Euler's method. If you have not yet watched the introductory lesson, you should definitely watch that first. This video will make a lot more sense if you do. You can either click the link in the upper right hand corner or find the link in the description. For problem number 1, we are asked to approximate the value of y when x is 0.2, and we are given all of the information we need to use Euler's method to do this. We are told that y prime is equal to x plus y. We are given the initial point, y at 0 equals 2, and we are told to use steps with width 0.05. The top row tells you how to do Euler's method. I want you to memorize this setup. I am providing this information for instructional purposes, but on the test or on the AP exam, you will have to make your own chart from scratch. The first two columns are for x and y, and we start with the initial point, 0, 2. We are looking for the value of y when x is 0.2. Euler's method allows us to find a series of points starting with the initial point and ending with 0.2, something, and that last y value will be our approximation. The step width tells us delta x, the change in the value of x as we move from one point to the next. So we can use delta x to find all of the x values. We just add 0.05 each time. So the initial x value is 0. Adding 0.05, the next x value will be 0.05. Adding 0.05 two more times gives us 0.1 and 0.15. If only we knew delta y, then we could add delta y over and over again until we got to the final answer. The problem is delta y is going to change for each point. So we are going to have to calculate delta y for each row. To find delta y, we start by finding y prime, and we are told that y prime is equal to x plus y. By the way, I'm switching to light blue right now because in the next two spaces I'm doing the calculations that will allow me to find the light blue y value. So y prime is x plus y, in this case 0 plus 2, so y prime is 2. The last column is for delta y, which equals y prime times delta x. In this case, that's 2 times 0.05. That's 0.1. So this is delta y. It's the change in y from the first y value to the next y value. So we can get the second y value by adding 0.01 to 2. So we get 2.1. After that, we just repeat the process a few times. The next column is for y prime, which equals x plus y in this case. So that's 0.05 plus 2.1, which gives us 2.15. In the last column, we find delta y by multiplying y prime times delta x. In this case, 2.15 times 0.05. Let's use a calculator. We get 0.1075. That's delta y. So if we add this number to the previous y value, we get the next y value. So we need to add this number plus 2.1. The delta y is already in the calculator, so we can just hit plus 2.1. 2.2075. Then we repeat the process again. It's time for y prime, which is x plus y. So that's 0.1 plus 2.2075, which gives us 2.3075. Then we find delta y by multiplying y prime times delta x. So that's 0.115375. That's delta y. So we can get the next y value by adding delta y to the previous y value. Delta y is already in the calculator, so we just need to add 2.2075 to this value. So we can just hit plus 2.2075. Kabam! 2.322875. Let's repeat the process one more time. Y prime is x plus y, so it's 0.15 plus this number. This number is already in the calculator, so we can just add 0.15. So I'm just going to hit plus 0.15, and we get this number. Write it down. Next, we get delta y by multiplying y prime times delta x. So we need to multiply this number times 0.05. This number is already in the calculator, so we will just go times 0.05. Times 0.05, kabam! This number. That's our delta y. So we can get the next y value, the final answer, by adding delta y to the previous y value. Delta y is already in the calculator, so I just need to add 2.322875. So I just hit plus 2.322875. Kabam! This is the final answer. And now is the only time I will round. I'm going to round it to 3 decimal places, so I'm going to put 2.447. Or you could truncate and put 2.446. Either way. So that is the approximate value of y when x is 0.2. And that's how you do Euler's method. For number 2, we are given the initial value y at 1 equals 4. So x is 1 and y is 4. They tell us to use steps of width 0.1. That means delta x is 0.1. We can use delta x to find all of the x values, because if you add delta x to the previous x value, it gives you the next x value. So in this case, I have added 0.1 repeatedly to find all of the x values. Next, we need to find y prime, but we are told that y prime is equal to 2 times y. In this case, y is 4, so 2y is 8. So that's y prime. In the last column, we find delta y by multiplying y prime times delta x. So in this case, that's 8 times 0.1, which is 0.8. This is delta y. So if we add delta y to the previous y, it gives us the next y, which in this case will be 4.8. 4 plus 0.8. Starting over for the second row, we need to find y prime, which is 2 times y. 2 times 4.8 is 9.6. Next, we find delta y by multiplying y prime times 0.1. 9.6 times 0.1 is 0.96. This is delta y. So if we add 0.96 to the previous y value, we get the next y value. 5.76. Let's repeat the process one more time. We need y prime, which is 2 times y. 2 times 5.76. There's 5.76 times 2. 11.52. So we have 11.52. Now we need delta y. We have to multiply y prime times delta x. So we need to multiply this number times 0.1. That's going to be 1.152. This is delta y. So we can get the next y value, which is the final answer, by adding delta y to the previous y value. So we just need to add 5.76 plus 1.152. Kabam! 6.912. This is the final answer. This is the approximate value of y when x is 1.3. For number 3, we are given the initial value y at 3 equals 3. So that's 3, 3. That's a lot of 3's. We are told to use steps of width 0.5. That means delta x is 0.5. We can use delta x to find all of the x values. We're just going to add 0.5 to each x value. Notice that we are being asked to approximate the value of y when x is 5, and here we are ending at an x value of 5. So here we go. We need y prime, which we are told is x minus y. In this case, that's 3 minus 3, which is 0. Then we need delta y, which is y prime times delta x. So that's 0 times 0.5, which is 0. This is delta y, so we can get the next y value by adding delta y to the first y value. But 3 plus 0 is just 3. Rinse and repeat. We need y prime, which is x minus y. In this case, that's 3.5 minus 3, which gives us 0.5. Now we need delta y. That's y prime times delta x. That's 0.5 times 0.5. That gives us 0.25. This is delta y. So if we add delta y to the previous y, we get the next y. 3 plus 0.25 is 3.25. Let's do it again. We need y prime, which is x minus y. In this case, 4 minus 3.25. That is 0.75. Now we need delta y, which is y prime times delta x. In other words, 0.75 times 0.5. That is 0.375. This is delta y. We can add this to the previous y value to get the next y value. This is already in the calculator, so let's just do plus 3.25. Plus 3.25. 3.625. One more time. We need y prime, which is x minus y. So we need 4.5 minus 3.625. So let's see. 4.5 minus 3.625. 0.875. Next we find delta y by multiplying y prime times delta x. So 0.875 times 0.5. This is already in the calculator, so I can just go times 0.5. 0.4375. This is delta y. We can add this to the previous y value to find the next y value, which will be the final answer. Delta y is already in the calculator, so let's just add 3.625 plus 3.625. Kabam! 4.0625. This is the final answer, or you can put 4.063 if you want to round, or 4.062 if you want to truncate. Either way, this is our approximation of the y value when x is 5. Number 4. Use Euler's method with steps of width 0.1 to approximate the value of y at 4.3, given that y at 4 equals 6 and dy dx equals xy. Show work clearly. This time they didn't give us the table, so we will have to do everything ourselves. Write the setup in the first row. X, y, y prime equals xy, and delta y equals y prime times delta x. Steps of width 0.1 means delta x equals 0.1. Y at 4 equals 6 gives us the initial point 4, 6. We can find each x value by adding delta x to the previous x value until we get to the target x value of 4.3. y prime is x times y. So in the first row, that's 4 times 6. So y prime is 24. Now we find delta y by multiplying y prime by delta x. So 24 times 0.1, which is 2.4. This is the change in y. So we can find the next y value by adding 2.4 to the previous y value. 6 plus 2.4 is 8.4. Now we repeat the process. Y prime is x times y. In the second row, that's 4.1 times 8.4. That's 34.44. Delta y is y prime times delta x. So that's 34.44 times 0.1, which is 3.444. This is the change in y. We can find the next y by adding delta y to 8.4. 11.844. Repeat the process one more time. Y prime is x times y, so that's 4.2 times 11.844. 11.844 is already in the calculator, so I will just hit times 4.2. 49.7448. Now we find delta y by multiplying y prime times 0.1. 49.7448 times 0.1 is 4.97448. This is the change in y, so we can find the next y value by adding delta y to 11.844. 49.7448 is in the calculator right now. I think I will go ahead and multiply that by 0.1 and then add 11.844. So I will hit times 0.1 and plus 11.844. 16.81848. So y at 4.3 is approximately equal to 16.818. Number 5. Consider the particular solution of dy dx equals 2x plus 3 with y at 1 equal to 2. Part A. Use Euler's method with steps of 0.05 to approximate y at 1.1. Write your setup in the first row like this. Steps of width 0.05 means delta x is 0.05. Y at 1 equals 2 means the initial point is 1, 2. We can find each x value by adding delta x to the previous x value until we get to the target x value of 1.1. Y prime equals 2x plus 3. In the first row, x is 1, so that's 2 times 1 plus 3, which is 5. Next, we find delta y by multiplying y prime times delta x. So that's 5 times 0.05. That is 0.25. This is the change in y, so we can find the next y value by adding delta y to the previous y value. 2 plus 0.25 is 2.25. Repeat the process one more time. Y prime is 2x plus 3. If x is 1.05, 2 times x is 2.1, plus 3 is 5.1. Now we find delta y by multiplying y prime times delta x. So that's 5.1 times 0.05. That's 0.255. This is the change in y, so we can find the next y value by adding delta y to the previous y value. 0.255 is already in the calculator, so I'm going to just add 2.25 plus 2.25. That's 2.505. So y at 1.1 is approximately 2.505. Part B. Find the second derivative. Well, if the first derivative is 2x plus 3, the second derivative is 2. Part C. Describe the concavity of the graph of y for x between 1 and 1.1. Justify your answer. Y is concave up because the second derivative is positive. Part D. Based on your answer to Part C, is your estimate for y at 1.1 from Part A an overestimate or an underestimate of the true value of y at 1.1? Justify your answer. Picture this as I read the answer and justification. Y at 1.1 is approximately equal to 2.505 is an underestimate because y is concave up, so the tangent segments are below the curve. Part E. Use integration to find the exact solution to the differential equation. We are given that y prime is equal to 2x plus 3. If we integrate both sides of the equation, we get y is equal to x squared plus 3x plus c. We are given the initial point y at 1 equals 2. This means if we plug in 1 for x, we should get 2 for y. So 1 plus 3 plus c equals 2. In other words, 4 plus c is equal to 2. Subtracting 4 from both sides gives us c equals -2. Substituting -2 in for c gives us the exact solution of y equals x squared plus 3x minus 2. Part F. Use your answer to Part E to find the exact value of y at 1.1. Y at 1.1 equals 1.1 squared plus 3 times 1.1 minus 2. So the exact value is 2.51. Part G. Was your answer to Part D, overestimate versus underestimate, correct? Yes. Y at 1.1 is approximately equal to 2.505 is a little bit less than 2.51. So it was an underestimate, just like we thought.